Welcome to today's webinar. I'm your host, Dan Eaton. I lead sales and partnerships for Speedata. Today, we'll talk about data center compute trends and how to accelerate the largest data center workload, what that does to improve data science and data engineering teams' productivity, unlocking data center capacity, and improving data center efficiency. Then we'll cover a customer case study. After that, we'll talk about how we integrate with Apache Spark, and we'll finish with an introduction to our analytics processor unit architecture. Let's begin. Digital transformation has created a tsunami of data across industries, and the data center struggles to meet the escalating requirements of the enterprise to process and analyze this tsunami of data. Data center capacity continues to grow. In 2022, Amazon, Microsoft, and Google spent over $100 billion in data center capex across servers, CPUs, and physical data center. Despite that huge investment, workload demand and diversity continues to stress the existing capacity. And today there's only 2% vacancy in Silicon Valley data centers and only 6% vacancy across North American data centers. And these workload demands are increasing dramatically. Today, the largest of these workloads is database and analytics. And I'm excited today to talk about a new architecture designed specifically to accelerate this workload. CPUs are great for a diversity of applications, and GPUs are fantastic for accelerating AI training and for specific HPC workloads. But what Speedata has done with our APU is built an architecture from scratch, specifically for accelerating data analytics. And because we built this architecture from scratch, we're able to get dramatically better performance per dollar and absolute performance versus CPUs and GPUs. The benefits of this new architecture fall into two major categories. First, data engineering and data science teams can get huge productivity gains because of this accelerated time to insight. The second bucket of benefits apply to IT infrastructure, cost savings, space savings, and power savings. And we'll dive a little bit deeper in each of these areas. First, we'll talk about that increased productivity from improving faster time to insights. So as the APU accelerates the time to insights for analytics pipelines and batch analytics, data engineering and data science teams gain huge improvements in productivity. On the left side of the screen, we've got a TPC DS benchmark using Apache Spark, where we've benchmarked first on a standard CPU server and then on a Speedata APU server, and we're seeing a 30x speed up across those TPC DS queries. Really exciting. And TPC-DS is a great industry standard benchmark that helps customers and partners understand how various technologies compare to each other. But what's even more exciting is customers and partners are benchmarking the APU versus CPUs and GPUs for their specific workloads, and they're seeing even better performance. Please reach out to us if you'd like to get a performance measurement of your workload running on APU. And these time to insight improvements that boost data engineering and data science teams' productivity also enable something else that's very exciting. The data engineering and data science teams, because they can now increase their productivity, they can answer more questions, make better decisions much faster, enabling the overarching businesses that ask these questions to get productivity gains. And we're excited to work with more partners and customers to establish the return on the investment in getting these productivity gains. Next, we'll talk about unlocking data center capacity. This is a really exciting area for me, as data center efficiency is what initially got me into accelerated computing over a decade ago. So what we've got here is a baseline around an existing enterprise analytics environment, looking at specifically their compute infrastructure. And that compute infrastructure is composed of 960 CPU servers. And that builds the baseline that we're going to compare against. And if a customer wants to look at getting the same amount of work done in that previous environment, they can dramatically shrink the amount of compute infrastructure required, getting the same amount of work done with just 7 APU servers versus 960 CPU servers. And the cost savings is substantial, moving from $10 million of compute infrastructure cost to just $300,000. But what we see with most customers is there's also an interest to look at how to future-proof analytics infrastructure. With that increase in the number of questions that the data engineering and data science teams are being asked, we have an option of applying the same budget to build out a compute infrastructure that future-proofs your analytics platform. And that platform, in this case, will move from 960 CPU servers to 250 APU servers. And that system has dramatically higher performance, 40 times the performance, but still unlocks a lot of data center capacity that could be allocated towards other workloads. Now let's double click on the energy efficiency of an APU system. So what we did here was we ran a set of queries on a CPU system and then ran those same queries on an APU system. And the system is exactly the same except for the addition of the APU. When we look at taking the time spent on those queries and multiplying by the energy used for each server, we can arrive at the total energy to run all of these queries. And the APU system shows a total power consumption reduction of greater than 11x, which is really exciting results. Now let's get into a customer case study. So this customer is a leading pharmaceutical company that's doing some research and wanting to compare compounds to other compounds. And as you can see from the right side of the screen, as you compare one compound to another compound and then move to 100 compounds compared to 100 other compounds, you have an exponential increase in the amount of compute required and execution time. So we looked at comparing against a baseline of 100 AWS R5 24 extra large instances. And to be able to compare 100 compounds to 100 other compounds, it was going to take 14,000 hours or 600 days, a little bit less than 2 years, spread across those 100 R5 24 extra large instances. So this is prohibitively long and expensive. What's exciting is taking that same query and using the APU to accelerate that query, we're able to shrink the time necessary from 90 hours spread across 100 servers to 8 hours spread across one server. Really, really exciting results. And Mark Ramsey, the former CDO of GSK, was really excited about the unprecedented performance of this solution and what it's going to do to improve drug discovery pipelines, and I'm really excited about the applications in healthcare and life sciences, and we look forward to working with more companies in the life sciences space to look at what this can do. Now let's talk about Apache Spark integration. So Speeddata's APU was designed specifically to accelerate analytics, and the first full stack integration that we've achieved is with Apache Spark. And Apache Spark has a fantastic, robust ecosystem, and that's one of the reasons why we chose Apache Spark to start with, is both the robustness of the ecosystem as well as the ease of integration. And our integration is at a level that it requires no customer legacy code changes. So data engineering teams don't need to change their Spark SQL. The other thing that's really important for customers is there's no change to the existing framework, in this case, Spark. And the last area that is really important for our integration is that customers can choose to incrementally migrate their existing queries and workloads to leverage the APU. They don't need to do everything all at once, and we actually recommend looking first to get the most bang for your buck, doing some workload analysis, and that's something that we've actually built a tool, the workload analyzer, to help customers be able to do that. So we look forward to working with you to profile your workloads and identify which ones will provide the most bang for your buck. Now let's talk a little bit about how all these benefits are achieved. And so we're going to look at Speeddata's architecture. So Speeddata has designed an architecture from scratch that's completely different from CPUs and GPUs. So the main difference in the architecture for the APU is it's based on building a custom data flow architecture for data analytics. And what that means is that data can come in and be decoded and decompressed in a stream, and each clock cycle, all of those columns of data can flow through the data flow processor, and every clock cycle causes massive throughput. So as the data is brought in and decompressed and decoded, then the data can have SQL operators applied to that data while it's still in flight. And finally, once those data flow pipelines are full, every single clock cycle produces results. In recap, Speeddata's APU provides substantial benefits in terms of data engineering and data science teams' productivity, as well as IT infrastructure, cost savings, power savings, and space savings. Thank you so much for your time spent working through this webinar. Really excited to follow up with any questions that people have. We had a few questions come in. The first question was around, is this implemented in an FPGA? And the answer is no, this is not implemented in FPGA. This is a ASIC. Again, thank you for attending this webinar, and if you have any questions, please reach out to me, Dan Eaton, and my email is deaton@speeddata.io.